shepherd right up and,
So,
sorry.
you remember we have the vendor-specific LCAF document under still working group last call, and which is concluded actually 2 weeks ago, yesterday. We did the consensus call in London, and this was just a check.
Right, did we get some decent numbers and responses? I'm trying to.
We had a few, but this was just confirmation of the consensus.
Right, so,
we
let's
can,
just pick it.
we'll send later on the forum. We can state it during working group updates. Let's see. And our first speaker actually. Shut.
Okay, yeah, I think it's a good idea. I was like, what? Getting better at turning the link. Oh, it is? Oh, we're doing this here. Yeah. Okay. Achievement, success, finality, all those words. Yeah. I'm not using it. It's HTML, right?
Yeah.
It means they're that's that. I think it so like here's the IT, right? Oh, okay. I thought you mentioned somebody. No. So you're a dragon. You're a dragon. Yeah. How many we can say? Yeah, you do. Good cheer. I see. Yeah. Yeah, they're great chairs.
Should we wait for the scene or we start? How do you think?
Hey Joe, how about if you do a Lisp tutorial from Daytime, but you do it for ILMP?
You can do it.
No, you were really good.
Talk to me. Well, will you do the same amount of work that Ran and Salim did in prep? They did all the material prep for
I
me.
will certainly help you. You want me to do everything and you present, we can work that out.
If the Edu team wants one, if you give me enough material so I can,
This guy right here could give a Lisp tutorial.
that would be good too. I have no problem.
So what is it, Sunday?
It's Sunday.
Sunday.
Actually, I may have a problem in Bangkok. I think there's a separate issue. Getting to Bangkok on Sunday is going to be fun
Yeah.
because I am supposed to be in Los Angeles Thursday and Friday before that. And it turns out that I want to use United, flying United from LA to Bangkok. You either connect on a morning flight through Narita, or nighttime you can fly through San Francisco to Singapore to Bangkok.
Right. That's brutal.
I don't get there until, if I leave,
Right. Anytime on Friday.
if I leave Friday night, I get there Sunday afternoon.
Plan a very good massage.
I've done lots of long flights before.
No, but like when did you get there? When I flew in, I actually walking through the airport, and there was a chiropractor. I was like, I've never done an airport chiropractic or ever done one before, but I had a pain in my shoulder. It's great.
Good to hear. Yeah, it's just the scheduling for November. I will be in Bangkok, but I'm not sure when I will get there.
Yeah, the Delta seats, they're like soft rocks. Victor set up Sunday session. How does that work?
That works. You talk to the edu team. They're really good. They want suggestions.
Oh, yeah.
So
Karen-
Victor volunteered. You see, he's motivated. Victor,
What's that?
you volunteer, right?
Karen
do the
O'Donnell.
tutorial.
The person you talk to is Karen O'Donnell. Yeah. She's actually with ISOC, but she does all the
He's
coordination.
done a zillion list presentations. You probably have tons of slides there.
Yeah, just don't have until the quarters.
Okay, should we start? A few minutes later. Then. Okay. So welcome to the Lisp working group. Okay. You see the not well, which means basically that whatever we say and do in the next 2 hours is a contribution to the IETF. Blue sheets are around, and one is just came back.
One's been brought back, there's one circulating.
Yeah, the usual pointers to the Jabber room, audio stream, Meet2Go, and the agenda slides. Okay, so to a brief update on the states of the documents. So since London, we have a new BIS document, which is the 6834 BIS. Yeah, it's about map versioning. Okay, we need to push this forward as well on the standard track. Okay, because all the 3033 bis they refer to this one as well. Okay, it's kind of blurry, but didn't find the right setup.
I thought this would be easy. I made it worse. Ignore me.
So then we have the usual intro and sec documents that are in standby at different stage. We have the vendor LCAF, actually, that was in working group last call in the last 2 weeks. This was just a consensus check because this document was presented in London. Authors asked for a working group last call. The room said, okay, there was consensus then, but there were few changes that I asked, editorial. So they came in a few weeks ago, and we opened the official working group last call. We had a few emails confirming the support. So I think we are done with this document. Later on, I will send a formal email on the mailing list, and then the usual process, shepherding, etc., etc. Now, as you can see on this slide, there are a few evil points, which is, so we have 3 documents, the BIS documents, plus GPE that are done, really done, okay? Even the write-up is ready. But I don't have IPR disclosure from all of the authors. Fabio, you included. So, so actually, you are on the GPA document.
Yeah,
And-
I get your emails here and.
Yeah, there are small editorial changes that I need to be confirmed, and IPR disclosure.
Remember, this IPR disclosure is not, does Cisco have, this is, do you know of IPR? Because presumably you know of all the things you should know of. So it's not, this isn't do a disclosure, this is, do you know of something that isn't disclosed? If so, then you have to turn around and do it, but tell us so we know to wait for that. If not, tell us so we can get this done. This is not an onerous thing.
I am the only author pending that?
No, there are others.
Okay,
Yeah.
cool. Thank you.
Yeah, I will continue ping the other authors on the BIS documents. Hopefully we will get a reply. Otherwise, we will write down in the write-up that we don't have IPR disclosure from all of the authors. We will send anyway forward the document, okay, to the ISG. The problem will kind of come back when we will have the 48-hour authors confirmation that where we really need confirmation from the authors. I mean, we'll see how to deal with that. Hopefully, in the meantime, we will get in touch with all of the authors. Okay. There is still concerning IPR. Actually, I forgot already last time to point out that we have to IPR disclosure about Lisp AID anonymity and Lisp predictive RLOCs. So both are from Huawei. You can check on the data tracker. I assume you can have more information about this IPR disclosure. And one last point, coming back to the BIS documents. So there is no IPR disclosure there directly, but if you go back and check the original RFC, so 6830 and 6833, they are IPR disclosure again from Huawei. So, which means that basically in the write-up, we will state that because the BIS documents are based on the original documents for which there is an IPR, so it may apply. Then it's not up to you to check this, but just point out these things. Maybe do not. I don't know. Okay. And that's it as an update. So coming to the agenda today, we have an update on the Young model. It's the only official document we will discuss. Reshad can already come here. And then we have a bunch of non-working group items. Mainly, Dino will talk about the console plane authentication authorization, data plane telemetry. Fred should stop by and talk about ground-based Lisp for aeronautical telecommunication network. Later on, Alberto will explain us how to use the Lisp control plane for segment routing v6. Okay, and to conclude, there will be Colin giving an update on the Lisp-based mapping system. Okay, and there are some spare time, so don't hesitate to ask questions and discuss. Okay, any comment? We can, I assume we can move forward and we go up from the. So, Young mode. I don't know why he showed up in this way. Pleasant, maybe. And it's too small. It's
Supposed to be a little button. It shows
I think I'll put my glasses on.
Can you select the display and set its resolution?
no.
Yeah, how was her? I don't know. Or-
Is this one a PowerPoint or is it a PDF?
Yeah. It's because
They work much better with PDF, I gotta say.
wait, no, there is. There is no fit the screen size. Let's see.
Right click with the movie. Control click.
With the exit over.
Yeah.
That's,
Is that better? Do you want me to try to
Okay.
convert my slides to PDF and send them to you, and I can come back?
I need to get this moving.
I can. Or I should tell a bank and we put my laptop on.
do you want me to present from my iPhone and then you fix that while we're talking? Or do you want to go in the order?
Yes, we can switch here. Yeah. I will convert to the PDF demo. PowerPoint. So you start.
Okay.
Which one I want to convert? So. Then you take it. Yeah. This one.
Yeah, I guess we'll start the list telemetry now. Can you hear me okay, back there? Mic working? Nobody back there is lifting their head, so. There you go. It doesn't matter, okay. So this was a really quick draft that we just put together a few weeks ago just to get something to discuss at the IETF. So basically the sneak preview is that we want this XDRs to characterize performance of the underlay. And we debate the RLOOK selection based on measured data of what the underlay is doing, with no extra support from the underlay, other than the ITRs and ETRs just talking together. Today, we already have our TT estimates because RLOOK probes can be time-stamped, and RLOOK probe replies come back, you can do the diff and do some RTT concepts. There is some hot count sort of information that you can use as well to know the number of routers in the underlay that you're traversing. But if decapsulating XDRs participate, more performance data is available and only. Test, yeah, that's better. Okay.
Thank you.
Okay. So if decapsulating XDRs participate in this telemetry feature, more performance data is available, and we can make better informed decisions. Like, you know what you transmitted on ITR, what you encapsulate, but you don't know what's being received on the other side, so you can measure different things like packet loss and bandwidth and jitter. So this was first, a list was put together. What the first 00 draft is doing is just identifying what sort of parameters we want and how to encode them. And then what later drafts will do is define how it's measured on the ETR. So after we do some implementation, we can say how we measure these things. But things like packet count, byte count, rate, packet rate, bit rate, bandwidth, those are all things that can be retrieved right now on the ITR, but packet loss, packet jitter, forward packet count, forward one-way latency, reverse TTL from the ETR coming back, and reverse timestamping. These are things that would be reportable by the ETR. So like I said, the early version is just showing that we send these things in RLOOK probes. Our RLOOK probe is sent, and the ETR has been measuring and collecting all this data, and it returns back in an RLOOK probe reply an extra RLOOK record. That's the JSON LCAF type that encodes all this stuff. And we want to use JSON because if we want to add parameters later, we can do it in a compatible way without changing the protocol, and arguably without changing the implementations as well. So that's it for now. Stay tuned for next revision. Questions, comments?
Eric, not Mike. And as I looked at the stuff, I realized that, oh, we should probably consider this coloring thing that people are doing at IPPN, right? There's this way, one way of measuring loss is you send N packets colored red, and then N packets colored blue, and then the receiver knows that, okay, it only received 98 that were colored red. And there's even some techniques to do this to get some latency measurement. So you need 1 or 2 bits somewhere, but you need to find a place for those bits.
Okay, it's good suggestion. Great.
I had two questions. One is, so reading the draft, the only XTR that asks about telemetry data is the one talking to you. So, and I can ask telemetry data about mappings.
Yeah.
Right? Why not other, I mean, if you are an XTR, why somebody else cannot ask you telemetry data about one mapping. Now, then you have to have a policy that says, can Victor knows about the telemetry of Luigi's mapping on Dino or not? But why not allowing this?
So what you'll see in my next presentation is that we probably don't want to give telemetry data to anybody who just requests it. So we want to actually sign map requests and validate them. So when you return the information, you know it's to an authenticated source. So that's one thing. And the other thing is if there's a source that wants to make its decisions unilaterally without having a management plane, we can make it self-contained in Lisp in the control plane. So if there's an application that's possibly co-located with the ITR side and wants this information, rather than running a separate management plane to retrieve the data and have all these separate APIs, it just has to ask about the forward and reverse data in one place.
Okay.
Okay. You want to switch back or do we keep going?
No, you have to keep going.
Keep going, okay.
So that what was switching then?
Okay, not yet. Okay, I'd like to give an update on the third revision of ECDS authentication. Eric's in the room, so he could comment or answer any questions. So we initially wrote the draft in July of 2017, and we presented it at that IETF, did one update, two updates, and we have another one planned for the summer. And at that time, we want to keep it as an individual submission unless the working group thinks it's good to make it a working group document, but I'll talk about that next. So just a brief overview of what the draft is. Basically, you can authenticate and authorize XDRs using the mapping system. And the way it does it, it describes how to sign map register messages and how to sign map request messages. And the map server actually verifies the signatures by looking up public keys in the mapping system. So we're introducing this concept of crypto EIDs, where part of the IPv6 EID is a hash of the public key. That's used when a message is signed. That crypto EID hash is used as a lookup to the mapping system, so the map server itself can retrieve the public key and then verify the signature. If the signature fails, the map register or map request is dropped. If it succeeds, then the next levels of authentication for a map register, the shared key authentication to see, are you authorized to register this particular EID in this instance ID is then checked.
Dino, if I may ask a question.
Sure.
How would that lookup of the hash fit with something like DDT, where it's supposed to be the tree is based on delegation? Just arbitrarily map it onto the tree, or?
Yeah. So the way we spec'd it out was the hash that you look up is appended to an ASCII string called hash dash. So it's actually a distinguished name as the EID in the EID record. And DDT can build hierarchy on any ASCII character in any string. So we've played with this before. So, here's the delegation for Joel, and here's Joel Helpern prime, and it's all subordinate to that. So you can break the hierarchy up, not on bit boundaries, of course, but on character boundaries, right?
Okay.
Okay. So what we also did is we recently introduced signature EIDs. The signature EID is a crypto EID, even though it's not one that you're using for doing IPv6 communication. It could still be used to authenticate other things that you want to send to or register to the mapping system or request from the mapping system. So some benefits, we're using the latest in digital signatures, lip to curve. That's why the draft is called ECDSA. And what the benefit is that you can actually
usually just agenda.
Yeah, I was there. Now he went to the Steve working group and then it goes back to the list of.
This is a, you think this is.
This
There you go.
Is it? No.
And you make it like los que sacan.
This page?
Oh, this good. Okay. One. All right. So list for SLV6. Yeah. So as you guys know very well, now that the list control plane database has been separated, we are taking the chance to see how we can apply the list control plane to different databases. So last time we presented list for ILA. Now we're talking about list for SLV6. And the tag work in progress really applies to this one because as we speak, we are discussing changes on the draft and on the way we do this here. So for the next iteration, things will change and we hope to refine as we go. But the basic idea that we have here is that we would like to use the list control plane to offer the SLV6 ingress nodes information about where they have to send the traffic. So as we put in the slides, list for where to go. So basically we map the EIDs, the endpoint MPNI EID instance ID to the egress SLV6 node and the VPN subnet on that egress SLV6 node where the traffic has to go. Then the rest of the stuff on SLV6 about traffic engineering, further route, all the stuff is still done by SLV6. So list for where to go, SLV6 for how to go there. So in the present version of the draft, in the 0.0, we cover like kind of the full picture, right? Where you have an overlay with mobility and traffic engineering being offered by SLV6. But we have received comments already about that we should be clear on that that's not the only scope of the document. So for the next iteration, we plan to clarify that, for instance, you don't need traffic engineering. So if you are interested into sending traffic from the ingress to the egress, that's perfectly fine too. So you don't need to go for the whole thing. But for now, we have covered, the difficult use case. Now we will narrow it down to more simple cases. So these are the basic ideas. Later on, I have some slides with examples that should help a lot to clarify how things work. But this is the basic idea of the draft. So you rely on the egress SLV6 nodes to register the endpoints into the map server as usual. And then we use a new LCAF to register the SLV6 needed information. So the ingress SR nodes that are going to retrieve this information can use it to first see where they have to go, so where they have to send the traffic, and also compute the appropriate traffic engineering policies and whatnot. That's the 2 points that are covered at the bottom of the slide. And then how you resolve the endpoints. So basically, we present two models in the draft. One where the ingress node requests the endpoint information from the mapping system, and it gets the exit PPN seed, so like the final SLV6 function that the traffic has to go to, and also that associated information that we saw in the previous slide, like the egress node, the traffic steering tag, and all that. So with that information, the ingress SLV6 node can go to the PC. This is like common SLV6 stuff. Can go to the PC and retrieve the SR policy to reach to that egress SR node. Then we also have another model where the ingress SLV6 node requests again the mapping system, and is the mapping system the one that takes care that takes care of talking, if needed, with the PC to compute the path through the SR underlay. And then the map server directly returns the list of SR hops through the underlay, so the Ingress SR node doesn't need to talk with the PC to compute that. So let's go through examples to clarify all this. So first, for what I call in the slides decision resolution, so going to the map server and then going to the PC, right? So this is the basic scenario that we consider. You can see there those A and C are the ingress and egress SR nodes. And on the left, you can see the information in the ingress node A as well as the information on the map server. And you'll see how the information gets populated as we go. And you can see there the endpoints that are attached to the SR ingress and egress nodes, and how you look at this one as a pointer, right? If you look here at the table, you can see how, for instance, A has 2 endpoints, right? And it has 2 decapsulation functions that point to the 2 verbs that guy is implementing. So when you want to send traffic to this verb, you will use this one and so on. And you can imagine a similar table for C. All right. So this is how things start. Map register. So the edges send the information about their local endpoints, the local EIDs to the map server as usual. And what they register is the information about, okay, if you want to go to this guy that is in instance 81, this is the egress SR function that you need to encapsulate the traffic towards. And this is the traffic steering tag, the color that you associate with that particular endpoint. So you can use that later on to communicate with the PC to compute the appropriate path through the underlay. So now let's say that you have traffic going from V to X. As you can see there, source destination, source address, destination address, payload. So what happens is common Lisp stuff. A map request, map reply. So you get that this line from the map request, map reply exchange, where the E node knows that to go to X, it has to encapsulate traffic towards C : D33, and that it can use the red color to find the appropriate path in the underlay. That is what A is doing in this step. It's talking with the PC, saying, I want to go to this egress SR node, and I know that the traffic has to be associated with this color, with this particular SLA or traffic stream tag or whatever you want to put it. So tell me the path. So that's what's happening here. And you can see that the SR policies are populated here. So the A node now knows that to go to the egress C, when the traffic is typed color red, it has to go through B. So that is what is happening here. Yeah, I'm not going to go into the details of how the SR encapsulation goes. So I guess that you guys can take a look at that on the Spring or go through the plenty of presentations that are around on this. But basically, you encapsulate the traffic through the service underlay to eventually be decapsulated in C and deliver as usual. So now mobility, which is what we covered with Lisp in the draft, right? So let's assume that X moves to a new egress point E. So this is regular Lisp stuff using a map register, and this map register, I've put both options in there. So I'm considering draft IETF EAD mobility and draft IETF Lisp apps up. Some of you may argue that only one is needed, and I could agree with that. So up to you guys how you want to deal with mobility. So you can use one, the other, or both. So they are all, as you know, interoperable. So I put them both there for reference. So basically, you update the. I was hoping Dino to come to the mic on this one. Yeah, go for it.
No, this is Dino. Just one quick question. We'll need to do pub sub or SMRs, even if the RLOC doesn't change, but the SR, the source route segment route that's associated with the RLOC changes, it looks like a mobility change and it has to be signaled to the,
Yeah, that's,
I don't know if that's specified in the spec.
that's in the next model. So in this model, we assume that the SR part is like compute by the, well, not compute, but it's retrieved from the PC directly from the ingress. So it's like disjoint from the Lisp retrieval of the final decapsulation point. But in the model where we collocate these two options, that is certainly the case. So if the SR path changes, you need to notify.
So in the EID mobility draft, this is a new setting a precedent, which is okay. The EID mobility draft said whenever the RLOC changes or has a new binding, we trigger map registers, we do SMRs, we do pub sub, we do data triggered SMRs, whatever the case for all those mobility cases. But I don't remember if the text says if the contents of the RLOC record changes versus the RLOC address changing.
Well, be careful, Dino, I want to interrupt you because what they put in the RLOC address is not the segment route. It's the label for the policy for the segment route to go ask the PCE. So,
I didn't want to bring that up because that's another issue I have with two-stage lookups. So
but they're not, the point is the way they're doing it in this version, this part, the mobility, that the policy didn't change. You don't change anything in the database.
Yeah, that's why I said that
So
it's in the second model where we don't need to get that.
This is not a criticism by any means on segment routing, but let's think of this. Let's look at just EID mobility running over an MPLS cloud. And let's say the label switches for the underlay. That's the same case here where the RLOC doesn't change, just the label changes because you have a new TE path. I don't know if we have language that talks about the characteristics of the underlay have changed, the how-to part, not the where part.
So in particular, if it's not there, it can't trigger.
The comment you made just made it more complicated because of the level of indirection.
I mean, then you get into, you'd have to trigger something to indicate that you need to requery the PCE, which there's nothing to change in the mapping system, so I don't know how you would do it.
Let's maybe go through the second model because I think your question applies more to the second model than to this one. So let's just finish with this. Once the ingress has been notified of the new attachment point for the endpoint, it will find, if needed, a new SR policy to go through the underlay. Traffic goes there. Okay, so now the second model is, I think, what Dino was asking about. In this model, the map server is the one that interacts with the PC to find the SR paths to the underlay. So things are like in the previous one. Let's assume that everything has been registered already and whatnot. So traffic appears on the ingress. Map request is triggered. What happens here is that the MSMR goes to the PC, or maybe it has gone previously and has something already stored there. So the map server goes to the PC and asks, okay, I want to know which is the SR policy to go to this egress because I have someone that is asking about an endpoint attached to that egress. So I want to send the whole path to that guy. So the map server gets that and sends back a map reply with the complete path, right? So in this case, the node A will have a map cache entry that says that, okay, I want to send traffic to X, so I have to use that SRv6 path that goes through B and then C using the decapsulation function D33. The traffic goes like in the other example. Mobility is the same, and in this case is where the mobility event triggers also that the path for the SRv6 ingress node to reach the egress node changes as well. And this is, I think, the case that Dino was mentioning. So let's assume that just the SR policy changes. So yeah, in this second model, the map server will notify like, okay, I've sent this information to you in the past, and now this information has changed. So here's the new information.
This is Dino. What if the SR policy doesn't change, but the reachability of the segment route changes?
In which sense? Like that you are not able to?
You have a segment route ABC, and there's a reachability problem between B and C. Is there any proactive fixing of that? Like go through A, B prime, C prime or something?
That's an SR question.
Yeah.
I know, yeah. maybe that'll go for it.
Darren Duke, Cisco Systems, and yes, the PCE would notify MSMR when that changes. The PCE would compute a new path and notify MSMR of the new path, which would then get distributed down to the ITR.
All ITRs.
Well,
All ITRs.
all ITRs or all ITRs interested, I don't know.
Yeah, same
Okay.
difference. And could be large.
Okay, so that's it. Also the example of the traffic. So we have an ongoing discussion on how we want to encode this part, and I think that Dino has an opinion on this too.
I just wanted you to comment on the issue we had in the side meeting about how to avoid the two-stage lookup.
Right. So in the draft right now, we have these two models: one with the two-stage lookup, another with a single-stage lookup. So for now, we prefer to consider these two as separate options that you may choose to implement one or the other. As we move on through the process of refining the draft, we'll see what.
So in the first model, the SR is directly in the RLOOK, in the LCAF, in the RLOOK record.
In the first model, the information needed to compute the SR path in the SR underlay is in the LCAF. Yeah. Yeah. Yeah.
Oh, okay.
And then, as I was saying, right, this is really work in progress, so things may change quite a bit for version 01. And at some point, once this is more stable, we want to go to a Spring and present there. And we also plan to have this at least an experimental implementation on FDIO BBP open source router, so we can play a bit with it. So that's all I have.
So, Victor, Cisco. Question on the second model where you have the single lookup. Once you get the update from the PCE, is the thought to actually push that update to the ITRs, or are you going to send a map notified to the ETRs involved and then let the SMR mechanisms take place, or are we thinking about restricting this to pub sub scenarios only?
Yeah, so if we follow what Dino was saying before, right? So once there is a change on the SR policy, PCE will notify the map server.
Yes.
The map server will see a change on the airlock information, and it will, well, it can do pub sub, or it can do pub sub, or it can do also EID mobility. Let's say that's pub sub, so it sends map notifies to whoever has requested that information in the past, right, or has been subscribed to that information.
Okay, it's clear for the pub sub, not so much for the SMR-based mechanism, how we do that.
Well, technically for the SMR base, you will send to the
ETR?
previous information, and then if traffic reaches that point, SMR will trigger map request, and you will get back the updated information.
Okay, so I don't know if we add text to the EID mobility draft or if we handle that in this draft directly.
Let's look at the EID mobility draft to see what the text looks like, to see if it generically covers this case without being specific.
Mm-hmm.
Okay, let's move on.
I just want to make a reference to Luigi's question, the list telemetry talk about why should the ETR give the information back to the ITR. This is a good example here where an ITR may have two RLOOK records. It's either the same RLOOK or different ones, but the point is that there's different, say it's to the same one because it's kind of interesting, but there's different segment routes. So you may want to RLOOK probe twice because you're going on a different path, and then when you get the information back, you want the ETR to tell the ITR, and it knows what path it is. Since these segments routes are source-based or relative to the ITR, you have this directionality problem. So we thought that it would be more general for that. Ditto for MPLS.
Okay, I have two questions actually. So you don't use at all the Lisp encapsulation. I understand, but you don't say anything in your document. In principle, you could You could, if you wish to use any functionality that comes with the
So-
Lisp encapsulation.
Technically you could. Yeah, so.
I mean, I think it would be clearer if in the document you have text that say, no, we don't want, or you could.
I think that's a fair point that you want to go for it.
I can respond on
Yeah, go
that
for it.
SR side of that anyway. You can, I think it was at the front of this document where you'd mentioned, Alberto, where, we went for kind of the whole enchilada right off the bat. We need to break it down into what happens if we are not doing TE. I think your question of doing Lisp encap and doing SR traffic engineering as well, maybe one that needs to be looked at in there as well. And we could expand on that, because I think you're right. This is with an SRv6 encap, but what about some other encap with the same SR traffic engineering?
Yeah. Okay, quickly to the second question, unless it's related to this, Stucky?
I have a new one.
I mean,
it's
it's
related to your point, though.
Okay, go ahead.
So can you go back to the ABC slide? So I'm glad Luigi brought this up, because it begs another question. Why can't A, B, and C be RTRs, and you encapsulate at each point and re-encapsulate? And if you do that, you get RLOG probing between each component of this source route. This is exactly what Lisp TE is doing with ELPs, right?
They could be.
And so one argues the question, why do you need segment routing V6? Because if you put that RTR topology in there, those links, the link between, or the underlay between A and B and C could be a combination of IPv6 and IPv4. Now, I know the answer to the question, but I'm glad he brought it up, because I didn't want to.
Go for it, Victor.
So you mentioned an interesting scenario where you're trying to basically break things down and show that you could actually have SRv6 with Lisp and no traffic engineering. And in that case, what are your thoughts on basically subsuming the PCE functionality into the MSMR? Would you need a PCE at that point? Okay. And then I guess the other point is, even if you have traffic engineering, it could be consolidated.
So actually, my second question is kind of related. I mean, why PC? Let me finish. So you have two models, integrated and disjoint, and it's pretty fine. Why you need to specify PC? Because you can just describe the two models in an abstract way and say, yeah, I need the traffic engineering information. Either the mapping system does it for me, or I do it.
Mm-hmm.
And then PC could be one example of how you do it, because you can have other control plane for the SRv6. So, I mean, if you want to put PC into this document, fine. But if you split, as I said, so you let it open in case you want to use a different.
Absolutely. That's what I was referring to. That we are planning to go more abstract for the next revision of the draft. So, perfectly fine what you said. So, agreed.
That could help answer the two lookup concern.
Yeah.
Okay, thank you.
Yep.
Fred?
Okay, good. Pull this up a little bit. I'll just hold the mic. So this is a talk that I've been giving this talk to the last couple of Lisp working groups. It was also given the routing working group this meeting. A simple BGP-based mobile routing system for the aeronautical telecommunications network. So some background. The International Civil Aviation Organization is building an IP-based networking system for worldwide air traffic management. And for those that don't know, ICAO is walking distance from this building. Their headquarters are just down the road from here. So they're developing what's called the Aeronautical Telecommunications Network with Internet Protocol Services, or ATN-IPS. It's in development in the ICAO Working Group I, which is like the IETF for civil aviation. It's IPv6 based and mobility capable, and it's going to accommodate aircraft with multiple data links. So an aircraft might have some satellite links. LDAX is a cellular link that's being developed currently. VHF links and Inmarsat, Iridium, you name it. Aircraft have many links when they're traveling. So we're looking at a BGP-based internetworking design where the BGP overlay network will be separate from the global public internet BGP routing system. It's based on a hub and spokes arrangement with regionally distributed stub ASBRs and centrally located core ASBRs. The stub autonomous system border routers advertise and withdraw mobile network prefixes that belong to planes. And the core autonomous system border routers form a hub autonomous system to forward packets between the stub autonomous system border routers. Proxies or XTRs connect data link subnetworks to the overlay, and clients that are aircraft that may connect to multiple subnetworks. Then route optimization removes the autonomous system border routers from the path. So what it looks like here is that think of it in terms of concentric circles. In the center circle, you have those purple routers that are core autonomous system border routers that are within the same autonomous system. And they talk using iBGP to keep full topology information. In the next outer circle, you have those green routers. Those are the stub autonomous system border routers, and they connect aircraft mobile network prefixes into the core. And then out in the next circle, you see what I've labeled there's proxies, but that's where the XTRs would sit in the Lisp model. And then finally, further out, you've got the client airplanes. And as you can see, is there a light on this somewhere? All right, I didn't want to do that. Okay. So you have some airplanes can connect to multiple data links. For example, if it has a SATCOM link through the first subnetwork and an LDAX link through a second subnetwork. And again, aircraft may have many data links that they activate during different phases of flight. So the details on the BGP arrangement here is that each autonomous system border router is a stub autonomous system unto itself. All core autonomous system border routers are members of the same core autonomous system. The stub advertised their associated mobile network prefixes, that's the prefixes owned by the airplanes, to the core using the eBGP. And the core autonomous system border routers originate default, but they do not advertise any mobile network prefixes to the stub autonomous system border routers. The core autonomous system border routers discover all mobile network prefixes in the system using iBGP, and they can connect the overlay to the global public internet, in which case they would advertise only a short aggregate, like a 2001 DB8::32, instead of dumping all the airplane mobile network prefixes into the BGP routing system. We've seen in past experiments that doesn't scale. This is kind of reiterating what I've already said about the hub and spokes model, and this is the diagram that comes from the draft. So changes since last version. We removed the discussion of route optimization and mobility and multi-link because these are covered under other drafts. We have the draft that's the Lisp, ground-based Lisp that talks about one proposal there. And I've got another draft on Arrow that talks about a second proposal. But this draft is now generic. It doesn't apply to either Lisp or Arrow directly, and either one can be fit in. We've had some discussions how the multiple systems can come into play in different partitions of the network. And the document focuses on the BGP topology and route interactions, and it emphasizes that inter-autonomous system mobility events and quality of service updates are not propagated into the BGP routing system. So that's pretty much it. Think of it in terms of concentric rings where you have your mobility and your multi-linking happen in the outermost ring so that the core doesn't get affected by that. You know.
Quick question. You said the planes are multi-home. Do they use both links at the same time?
They can.
And what's the addressing when they're using both at the same time?
They use the same EID over both links. And so EID prefix, I should say. Okay. So you might have differentiated service code points point to link A for some traffic and point to link B for other traffic.
I see. Okay.
Yeah. I think that's it. Let me just check. Oh, okay. Here's the draft. Again, it's been presented at ICAO working group by mobility subgroup, and it's under active consideration there. And it was been presented in the routing working group at IETF 99, 101, and also 102. It was just presented on Monday. And also presented at the Lisp working group at IETF 101 and 101. And also now this one at 102. So I think that's all I have. Any further questions?
Have you considered using both Lisp and BGP at the same time, like just use Lisp on the proxies? Does that make sense?
That's what we're thinking about.
Oh, that's your thing.
Yeah, that's what we're thinking about doing. Okay, thank you.
I have just a curiosity. When will ICAO make a decision? I mean, they're considering this solution, right? So what is the time frame?
ICAO is really kind of pushing forward to get a solution decided on soon. But whether that solution would be a pure Lisp or a pure Arrow or a pure mobile IPv6 or some kind of hybrid of those, that's what we're kind of in the process of trying to decide right now and figure out.
Hi, Brian with Nexus. I actually just was wondering if you were considering using the planes as sort of a mesh network so they could relay each other's packets.
That's a very interesting idea. So air-to-air links, are you thinking about that?
Yes.
Yeah. We think about that when we talk about drones, when we talk about unmanned aircraft, the small drones, We haven't been thinking so much about the civil aviation airplanes, but that's certainly something for us to consider. Okay, thank you.
Thanks for that. So the last presenter of the day is Colin.
Hello, everybody. This is my first presentation, so we'll hope it goes well. Make sure to shoot questions, give comments, let me know anything I may not be seeing correctly on this, but this is essentially something that and I've been working on, kind of speculating on for a while. A little background: I work on peer-to-peer networks, cryptographic distributed ledgers. So we've kind of had some interesting interactions, figuring out how we can kind of integrate some network level components to distributed ledgers. So that's kind of where the birthing place of the decentralized mapping system came in. Essentially, if you have a peer-to-peer network valued in hundreds of billions of dollars, let's say Bitcoin for an example, and it's running over Lisp, you need to basically mitigate central points of failure, which mapping servers can potentially be, which could essentially bring down the entire network and cause significant damages monetarily. So what if Lisp SCRs didn't rely on pre-configured map servers? And what if map servers could also allocate to their own shards when they came online? Now, what if the abstraction layers on top of the OSI could actually improve key management and authorization in map servers? And what if we could mitigate map server DDoS attacks through partial pre-image collisions of 0 bits? So what this basically means is we can distribute the XTRs on the map servers and make them auto-allocating as a type of distributed consensus mechanism, so that they can allocate specific shards within one another, and then from that, they can create a higher level of reliability. Now, this is gonna mitigate DDoS attacks. I'll get to that about the partial pre-image collisions. That's essentially finding a number of 0 bits that are a partial pre-image collision on any type of hash with a random n once that would essentially be a proof of work that would create an asymmetric type situation, which means that the requester would be required to fulfill thousands more hashes than the actual verifier or the map server, which will only be required to fulfill one, so you could drop packets, and I'll get to that later. Sorry, I'm going on a tangent. So, sharding the map server. So, what if each XCR was a map server allocated to a DHT shard, so a distributed hash table? And what if each XCR could actually map registers to each XCR based on deterministic modulus? So, essentially what you could do is every time a new map server came online, they could replicate one another, and then they would be acting through a shared type of address registry that we'll get to that with the DNS, which essentially would be able to create and allocate new shards. So it would, in a sense, share some of the cache, and new nodes coming on that are aware of new map servers would essentially be able to start asking or talking to these new shards with new caches, and then the map servers would eventually cache and time out since some of the records would go, and so it would automatically be able to locate and create shard 4, shard 5, or shard 6 as needed. So this would be something that would be determined by the map servers. It would probably require a little extra machinery, but it would allow them to essentially auto-synchronize and auto-manage themselves. So the DDoS protection. We always have the needle in a haystack problem with DDoS attacks. What do we do if a central map server goes down under a DDoS attack? Does this cripple the network? Now, what if the server load determines the location on the DHT charge or map servers and also acts to require requesting party to complete a proof of work by iterating an N once to find a value that meets a number of 0 bits, making it require work for the requester if the server happens to be under a heavy load. So if you have some sort of minimum threshold that the map servers will locate new shards at, let's say, 30% over a moving average window, you'll be able to reasonably determine if the server load goes above 50 or 60% that you're under some form of DDoS attack, which you can throttle requests from all parties by requiring, let's say, 100 milliseconds or 500 milliseconds of actual proof of work, which would be easy to verify on the map server side. It would slow down requests on the requester's side, and it would allow the map server to resolve that load and reduce it, which would improve the actual accessibility for the end user. Now, the downside for the user is they would require computing cycles if the server did get under heavier load, but if you're under a DDoS attack and the server is completely down, that's completely service outage. This would just be a slowed service, which would require you to essentially pay your dues to get access to the system. So how to shard the mapping system? So as Joel brought up last time when we went over the Lisp decentralized draft, there was a bootstrapping problem. So the DNS record would simply be something that is pre-configured that would talk to a DNS type of map server that would just be keeping a running record of all of the actual distributed map servers. So this would be the way that you get through the bootstrap. You can figure that in. And then the DNS server is essentially what you get the A record for, which then you talk to it over a predefined message set and ask it directly back for the list of running map servers or shards. And then you'll know exactly ones. Now, if a shard is in bootstrapping phase, which could be a 24-hour phase, creating, let's say, shard 4, then you would be essentially talking to modulus 3 and modulus 4 in order to bootstrap and help that map cache fill up to eventually get through that bootstrapping period to where the new shard can allocate. So the XDRs that are part of the mapping system resolve the first DNS records to obtain the initial DNS seed, which then resolves to return a list of known map servers. Map registers are sent to the correct shard, located by deterministic assignment of modulus. So an example would essentially be, we have 3, and then the new allocation there would essentially be getting map register requests that would still be having the cache. Let's say if it was in mod 2, in the original shards, it would be getting new registers in mod 4 and mod 2, but eventually the more of them that started to become aware of this new shard would eventually cause all of the mod 2s to time out, and then they'd eventually ignore it so that they could automatically synchronize into new shards. So the DDoS request throttling, what if the map servers can essentially use the EID as a part of the throttling mechanism to do the individual? Now, when we have a DDoS attack, we have the problem where somebody could be essentially manipulating the source or the destination and completely spoofing all the IPs. The problem that we can have there is the needle in the haystack problem. So we resolve that through the CPU collective usage and use that to essentially say, well, if you're making me work more, I'm going to make you work a little bit more. And then that's the global to do the DDoS. Now, if it's just a DOS attack, then you could easily throttle that by saying, if you're making too many requests per second, then we're going to slowly increase the amount of 0 bits that you're required to do, which is going to increase the computational requirements for you to send a message. So all you have to do is verify 1 hash and then drop the packet if it doesn't meet the proof of work requirements.
There seem to be mixed at least two different sets of requests in this, which come from different parties, and I'm a little confused about that. There's map registers, which come from other ETRs. Well, wait, the ETR is one of your DHT elements, so it wouldn't be sending map registers, so there probably are no map registers. And there are map requests which come from ITRs to map requesters, not map servers.
Okay.
And now who's going to prove work? Because the request has to go across the DHT to the guy who has the authoritative thing. He's going to ask somebody to prove work, but it looks like he's asking the trusted party to end up doing work because the trusted party is getting besieged with requests, which he has no way to ask for proof of work.
It would be agnostic to the message. And you could also theoretically scale it based on the actual, let's say, computation requirements of each message. So that's still something that's being thought out, but this is kind of the theory being put in place.
That doesn't answer the question at all. My point is, map requests come from ITRs
Yes.
to the edge of the mapping system. Those, you haven't talked about those entities in this slide at all. So obviously, apparently, those aren't asking for proof of work. So the proof of work is coming from the guy who has the authoritative information. Well, by the time you've gotten it to him, asking somebody else to prove work, A, seems to be the wrong question, and B, he's asking the wrong party. He's actually asking a trusted member of the mapping system to prove work, not the ITRs, unless you're also changing things to assume that ITRs are members of the mapping system.
In a decentralized system, the word trust is something that is generally disregarded because anybody could be a malicious actor. So this would be something to mitigate that in a certain sense in case even a map server could be malicious.
So you're saying that what you're trying to deal with is a very different DDoS than everybody else worries about.
There's a lot of different factors, yes. And I'm not saying that I have the answers for all of them. This is just a preliminary architecture in order to maybe facilitate the idea of a potential use case in this as far as mitigating potential risks of DOS or DDoS on whatever layers of the network.
I don't think it's that general.
Okay, well, I'm speaking about it in a general sense, so I apologize if I'm not so explicit. But anyhow, yes, sir.
Just a quick comment. So separate all the XTRs being part of the mapping system from DOS attacking the mapping system. Because we could DOS protect the mapping system when it's not decentralized. Okay, so think of the mapping system as you know it today, and it's being DOS attacked. How could we use proof of work to slow down attackers? And
But that is a major change, not to the mapping system, but to the interface, which we have defined as stable. Now, we can evolve it, but that's what I was trying to get at, is the difference between mapping system operation. We've structured this so that putting in a new mapping system is transparent to the external interfaces.
Yes.
And changes to those external interfaces. It looks like this takes changes to those external interfaces.
Right.
That's not out of the question.
Right.
But we
You
need
just want
to
to make
be
it
clear if
Yeah.
you're going to present it here
Yes.
about that distinction.
And from what I understand, you wouldn't need to modulate too much of the packet structure. You would be able to use the nonce that already exists within it and then just check the 0 bits as far as the checksum of the hash.
We'd need some extra messaging to say,
A little
you
bit,
have to
yes.
meet this constraint.
Yes.
That's new messaging.
On the map reply message, that would be exactly where you could send. We were talking about using a few high order bits or something within that, since there is 64 bits number space, you said, Dino, correct?
So the idea would be, Joel, that the ETR would do the proof of work and the hash doesn't have to be sent in the map register, only the nonce does. That nonce we already sent today. Now, what is said on the other side is that the guy takes the nonce, hashes the packet, and then he gets the hash and he knows if he's good or bad. Now, as you want to change the level of difficulty, we know we have a map notify that's an acknowledgement to the map register. The map notify that you send back could have the difficulty value. So as the DOS attack increases, level of difficulty for proof of work increases.
All I was saying was you have to put something new in the messages so that you know what the difficulty level you got to meet is.
Yep. And I mean, I'm not saying that it's going to be perfect, but I think the potential risk that could be mitigated, especially getting Lisp in a decentralized environment, could be pretty
We'll
profound.
get back to that goal.
So, yeah.
Alrighty.
So it sounds to me like you've got two things here: the decentralization of the mapping system, and this in its own right as its own idea. Should these be two separate documents?
That's probably more appropriate. Yes. Yes.
Keep going.
Okay. So I apologize for. I'll do better next time. But okay. So anyhow, so then essentially what you can do is you can have certain types of attacks. Let's say ECDC verify and Lisp crypto. That would be done through a CPU exhaustion attack. So by being able to throttle and create the asymmetric proof of work, you would be able to essentially require the end party that is doing the request or any sort to basically require it to do a proof of work, which would throttle them. Now, the benefits are the XCRs only depend on each other, and so they already, if they want to talk to each other. Now, no third-party trust or dependency exists. Maps Request Locus has low latency, and map servers have redundancy and scalability. Those are important components to get into a complete decentralized environment, to utilize Lisp with something such as a distributed ledger. So the distributed ledger is an abstraction layer on top of Lisp or on top of the OSI reference stack, can actually handle the removal of native third parties, such as key management, authorization, access control schemes. Since the distributed ledger is actually a very secure data layer that is built through a consensus mechanism globally, there's a lot of things that you can actually be implementing on a Lisp. So the prerequisites defined in this document are their prerequisites defined to make the decentralized mapping system function in a case that would eventually allow a distributed ledger to sit on top of it, which also allows you to create reputation systems mathematically verified on EIDs so that you know exactly who you're talking to, and then you can have certain, let's say, selection bias from the Lisp telemetry data on the distributed ledger, and vice versa. If a map server can verify EIDs or RLOGs that are mentioned into the distributed ledger and verify their actual trust and reputation, there can be implications in that as well.
It sounds like there's a real assumption here that's very important and valid for some of the use cases you're describing, but I want to make sure I'm understanding you. Your assumption seems to be that this is an environment in which not only are the XTRs highly distributed, but any XTR, it is perfectly okay for any XTR to claim to be serving any EID as long as nobody else is claiming that EID or EID prefix.
No, when you have the distributed ledger on top of that, you actually create a reputation system, a series of events, so that somebody's claim is not just a claim out in the open abyss. You actually have a mathematical verifiable trail of somebody's trustworthiness, so that you can have a distributed trustless system by mathematical verification.
Okay, that's going to be, okay, you're going to need, if you want to claim this applies to a lot more, you're going to need to provide a lot more details on how that's related, because frankly, it would take way too long for me to unpack what you just said.
You're absolutely
in
right.
this room.
And this presentation is kind of a mix of 3 different components: the DDoS throttling, the Lisp decentralization with the automatic location of the maps, and then the distributed ledger technology. I could go in, I've been developing distributed ledgers for about 4 years now, so I have extensive experience in that. I've been running a live one for about 3.5. So I could get into a lot of details, and I'll probably author a draft on the DDoS and then the distributed ledger technology on top of the OSI.
Well,
and
just be careful.
continue upon
If
this.
you want to treat that as separate, then you're going to create a dependency between the 2 drafts. And the DDoS thing, it looks like, is really separable. And I'd like to be able to evaluate that separately, because I think it's potentially interesting, but very separate.
Cool.
The relationship about who is allowed to register what and how that is achieved is central to the notion of what the mapping system does.
Okay.
There's a whole lot of work in the register messages and in the authorization models we've done, and that doesn't mean we have to stick with them. And maybe we want to offer alternative ones as well, but it's very important to address.
Yes, yes. And I think that can be addressed with the distributed ledger. So in our next revision of this draft, we will continue forward on explaining and extrapolating on the implications of that.
Yeah, this is Victor. So Joel, if you keep them as one document, right, all those uses of the distributed ledger, et cetera, would only be applicable to the decentralized model of the mapping system, but they may be applicable to a centralized model.
That's
Yeah, there is
but I'm trying to-
implications. Yes.
They can be separate, but you need to be careful about how they're related. That's all I
Yeah,
said.
okay.
Yeah, the DLT is just a secure data layer that's formed through a global consensus, which makes it very difficult to forge any data on it, because instead of having, let's say, conventional Byzantine fault tolerance of 30%, 3L+1, you end up having multiple layers of validation that become incredibly costly to forge and create, which allows you to create a track record of cryptographic identities and keys that then you can then use through authorization systems in centralized or decentralized mapping systems.
So regarding the last bullet, Albert's been doing a lot of work with his team on how blockchain technology in general could help Lisp. And there's ideas on how to enhance the mapping system, how to do prefix openness and allocation and stuff like that. So
DNS
I think
record,
you should,
Yeah, there's a lot of implications on it. And I mean, I believe that the OSI as we have it works to a point, but the need for so many third parties is kind of showing that there needs to be more layers onto that stack. And I think the distributed ledger is one of the layers that could sit possibly even in the application and presentation of the OSI, and then so on and so forth to create kind of the auto-executing environments and tie financial instruments into it.
I noticed that there was the need for DNS to begin with, right?
Yes.
Now, if the following the intent, right, that the intent is to get away from the relying on the third-party elements as much as possible, but then you still have to rely on DNS for the seeding purposes, I guess, right? So does that somewhat reduce the efficacy of the overall solution? I mean, here, the way we want to decentralize it, but we are going back to the third party.
Not necessarily. If you were passed an IP address of your friend that was already connected to the network and they said, you can use my IP address, you can hard code that directly in or put it in your configuration file and it would function the same way. All it's doing is functioning to give you the gateway into the network. Once you get in the network, address discovery happens automatically. So the DNS is kind of a convenient user way in order to get access to the network. But if you want to not rely on it, that's perfectly possible to do. You just need to know the IP address of a gateway to get the initial address seeds.
Okay, I mean, what if DNS gives me the response that I shouldn't have had, right? So
DNS, generally you're not going to want to rely on one domain name. So in Nexus, what we do right now is we have a set of 20 or 30 different DNS records that act as the first nodes that a node ever talks to, which then gets the seeds of all the other nodes that are accessible, and then it goes and it starts connecting. So you do that through redundancy by having multiple DNS records. If one of them resolves to an incorrect address, then that port's not going to be open, and you're not going to be able to make that connection, and you're just going to discard it.
Well, if it is open and it's malicious on the other side, that's the possibility I'm thinking about.
It's possibility that's malicious, and that's the beautiful thing about distributed consensus is you don't have to just talk to one node. You generally talk to multiple ones. So if they do give you a list of malicious addresses, that's why you do the full validation of the ledger on your local node and verify all the cryptography. So even if they try to send you malicious data, you're going to be able to detect it and it's going to be invalid.
Assuming that they don't have the consensus. They don't have the majority.
If yes, and that majority would come generally in your context saying that would be called the Sybil attack. But in this sense, it requires an incredible amount of computing power through proof of work and also other mechanisms through proof of stake validation processes to actually make those cryptographic blocks. So it wouldn't matter if you talk to an invalid one. They could give you a bad blockchain or a bad set of blocks and you're going to be able to verify with your neighbor they're correct.
Okay, thanks.
Yep.
So I wanted to address your comment. So I asked, I mean, many people have asked this question before, what's the decentralized internet? And I like to think of it of a way is, if you use DNS, are you depending on a third party? Well, you may be depending on a third party, but you can still be decentralized because it depends where the third party is and who's managing it. So I like to think of it this way. If we use something like Lisp Decent and every XTR is a mapping system or a map server of the same mapping system, I like to think of it as a neighborhood of devices that have local connectivity that send IP packets to each other. They want to be self-sufficient. They want to run themselves. They have no connections to the internet. But maybe if you don't have multicast, which is, if you have multicast locally, then you can do everything dynamically, just like we see how Bonjour works in our house with Macs and stuff like that. But if you don't have that multicast for some reason, you can still depend on DNS, but the DNS is all local and trusted among that trust group in that neighborhood. So even though you're depending on this protocol that looks centralized, it's being deployed in a decentralized, trusted environment.
Now, as far as I know, none of the arguments for deployments we described for Lisp match what you just described, Dino.
Agreed.
They tend to be scattered around the internet, not locally connected, or they tend to be under, if they're serving a single data center, which is the opposite case where they are clustered, they're under a single administrative control, and so you don't have a distributed trust problem.
Right.
So be very careful about describing the problem, because I run into this a lot with people saying we could use blockchains for foo. Well, you could, but it doesn't actually match any of the properties of foo. Blockchains have interesting properties. I get that.
Well, it's supply chain management and auditability and immutability of the data. So that's where you create trust, where it's mathematics that becomes the verifier of truth. So in a sense, you could call a blockchain or a distributed ledger a truth layer of the internet, which is something that we don't really have. Now, the truth is determined by global consensus, and the more people you have validating in that consensus, the more you could consider that truth. So it essentially gives you just layers of abstraction that help give an improved frame of reference. I would never speak in absolutes about it, but there is a significant improvement that can be done. Okay. So this is pretty much almost over anyway. So why decentralized? Well, it's important. The internet, the IETF was designed to be decentralized. The internet was designed to be decentralized. It makes it more robust and it removes it from central points of failure and also for central points of control. So peer-to-peer networks, as we've seen, they're starfishes and they've proven high levels of robustness. You have 100% uptime and you don't have to have, let's say, any point of central failure. Now, you always have fallbacks if a map server gets put under a DDoS attack, if you have the distributed mapping system. Now, as Joel said, there is certain trust issues that need to be associated with that, and that's where the DLT hopefully can help. Now, distributed ledger technology relies on the robust nature of peer-to-peer, and so to run Lisp reliable on such a network would require this distributed topology, which makes it very interesting where you can punch through the NATs and get through the RTRs, which is a big problem of getting the full mesh topology and what we exist now, which is something that Lisp is actually bridging for Nexus very significantly. And also the decoupling of your routing locators to your endpoint identifiers and being able to tie that to a cryptographic identity so that you can actually be reached and I can know somebody is somebody and they can prove who they are by signing from a specific key on their signature chain. And I can look up, not just from that EID, I can look up their whole track record if they've validated, if they've had any spends, if they've created this, if they've had loans, if they had escrow contracts that failed and so on and so forth. So it just gives you a better auditable trail of events that you can use to create better selection bias, whether from EIDs or map servers or anything.
So
questions, reactions?
So I just wanted to add it to your last point.
Yes.
So the idea here is that crypto EIDs give you identity at the network layer, and cryptocurrency wallets give you this identity that is very changeable because you have different set of parameters when you want to change it at the application layer. The question is can the security of this application layer help the network be more secure and vice versa? Can Lisp security help the application be more secure?
That's an idea with the layers of abstraction. So if you add, let's say, a ledger layer on the OS side, then that ledger layer could have an API that's accessible from the Lisp layer or layer 3, which then be able to ask the ledger about certain things or certain EIDs or certain map servers and be able to get actual data from there so that the network layer can be less spoofable and vice versa. When the ledger can actually recognize EIDs through that and have trust, and they're going to know that nobody can spoof an ID. You can spoof an RLOC, you can use VPN, whatever, but I know I'm always talking to the same EID, and I see the cryptographic proof that this person is who they are based on the distributed ledger. Any other questions, comments? Cool. Thank you, guys.
So we don't have any more presentation on the agenda. So we have few minutes, like 10 minutes, if someone like Dino wants to bring something up to the mic.
I just want to know where we are on the decision on the OAM document, and is that holding up the BIS documents? Do we have an OAM document? If we don't have an OAM document, are we losing the text that we pulled out?
So they are not blocking the BIS documents because there is no reference to the document, which is not existing. I sent an email to you and Albert about where we are with this document. So it's up to you to answer the question. So you personally said, I don't want to write it because I don't think it's the right solution. So I don't care, basically. Yeah.
No, I care.
Yeah. So
since I don't believe in it, I don't want to write the document, and I'm not going to speak for Albert.
To be honest, there is nothing to be wrote. I mean, you just take the text, you put it in an XML format, and you submit it.
We're not questioning the effort of building a separate document. It's the principle of having it in a third place that's not helpful.
We are, however, to get to the rest of your question, trying to get everything else unstuck. So we were working on the Shepherd write-up for the 6634 BIS. We're trying to get everything else out the door. It's taken longer than we like. We want it done.
We understand. We're at a stalemate.
No, that's not blocking. That's what he said. We're going to be moving that on without regard to the other. We're not waiting for it.
Right, and my greatest fear came true. We're losing text.
It can be recovered by somebody, you or somebody else, putting it in a separate document. But it doesn't block our getting the stuff to PS, which we really want.
OEM is part of the charter or it is not part of the charter?
Sorry?
OEM is part of the charter or not?
Good question.
I believe it's a chartered work item, but it's not, doesn't have to be part of getting to PS. We want it. That's not the question. We didn't think it will fit well where it was. And so that's not where it is. And frankly, if nobody cares to put in the work to put it back together, that says something about the working group's actual interest in that work. That's a problem, but it's a different problem.
It's not a question of interest in the work. People have implemented that text.
Fine.
And it's going to be lost, and the only way to recover it
It
is to
will
point
not be
people to
lost.
6830, right. We will point to the experimental RFC, not the
No,
standards RFC.
somebody will write the danged RFC we want for standards track that says what we want to do.
Okay, let me try let me try to have a different perspective. Okay, I think that text within the right context had value, and the right context was the rest of the text, the rest of the RFC. Now, what you're telling us is you can take that text and put it somewhere else. But I think that when you do that, it loses the value. So it's not that no one cares about that text. It is not true that since no one is willing to do that, this means that the text has no value. I think that when you do that is when you lose the value of the text.
Well, this wasn't just the chairs going, well, we arbitrarily decided, we talked to the working group.
That's true. Yeah,
it's not that we just said, well, we don't like it. I try to stay off my high horse. I like writing. I do it very, very rarely and badly, but I try to stay off that. But we asked, folks agreed that it was better to remove it. So that's why we're advancing it without it. You know how the game's played. Okay, we're done.
Good first time. Thank you. Yeah.